Hello everyone and welcome to my latest Rust Quickie. In my previous two Rust Quickies I have talked about immutable and mutable references in Rust, and today I want to show you what happens internally in Rust when you try to create multiple references in parallel to objects which were allocated on the heap. So let's switch over to Visual Studio Code, where I want to demonstrate those things in more detail to you. The first fact that I want to talk about are multiple mutable references. As you can see, I'm using here the same code block as last week. We're defining a vector called databases. It's allocated on the heap. We're pushing some string values into that vector, and the current owner of that heap allocated memory is the mutable variable databases. And one of the first facts of Rust is the fact that there can be only one mutable reference to a memory which was allocated on the heap. As you can see here, I'm defining here two mutable references to that variable databases. But multiple mutable references are not allowed in Rust. Currently, we don't get here compile time error. We're just getting here a warning that we have an unused variable reference 1, an unused variable reference 2, but as soon as we try to use those variables, for example, I'm calling here the function print vector mutable reference that you already know from my last quickie. You can see as soon as we are calling that function and we are using those mutable references, we immediately get a compile time error by the Rust compiler. So when we try to build that one, you can see now we have here at reference 1 a first mutable power, and at reference 2 we have a second mutable power, but the second mutable power is not allowed anymore. So this is very, very important. There can be only one possible mutable reference to a memory which was allocated on the heap in the current scope. What does this mean in the current scope? Our current scope is here that whole function. So you can have multiple mutable references to some memory which was allocated on the heap when you put those mutable references in different code scopes. I have here a second implementation of that function, and as you can see, again, I'm defining the vector, and then I'm just creating here a new scope, a code scope. I'm defining here the first reference to my database variable. It's again a mutable reference. I'm printing out that vector through the function that you already know, and as soon as we are leaving that scope, the mutable reference is automatically trapped by the Rust compiler, and therefore we can acquire in the next step a second mutable reference, which we can again print out. So we have defined here two mutable references, but they are in different code scopes. So at one point in time, there is still only one mutable reference allowed. So this is very, very important here. If you have some heap allocated memory, there can be only one possible owner which can write to that memory. So this is the first key fact that you have to know when you are working with mutable references in Rust. A second key fact about multiple references in Rust is the fact that you can't define a mutable and immutable reference to a variable at the same point in time. Imagine the following. I'm defining here a mutable reference to my variable databases, and afterwards I'm trying to define an immutable, a read-only only reference. As you can see, we are getting here immediately a compile time error. We have at reference 1 a mutable power, and as soon as you have a mutable power, as soon as you have a mutable reference, nobody else can acquire any reference to that variable anymore. So as you see, when we want to acquire a immutable reference, we immediately getting a compile time error by the Rust compiler. So this is very, very important. When you have a mutable reference, you have one exclusive owner of that heap memory, and nobody else is allowed to read that memory anymore through an immutable reference. And of course, nobody else is also not allowed to change that memory through another mutable reference anymore. So this is very, very important here. When we go down, I have here a second implementation of that function, and as you can see here, I have swapped here the references. In the first step, I'm acquiring an immutable reference, which we can only read, and in the second step, we acquire an mutable reference. This is allowed. Means when somebody is reading some memory, someone else can afterwards acquire a mutable reference. As you can see, we are not getting here any compile time error, but as soon when we try to acquire a third reference, a mutable reference, again we are getting a compile time error. When we try to acquire an immutable reference, we are also getting a compile time error. So it's very, very important. As soon as you have acquired a mutable reference, you are not allowed to acquire any other reference anymore. So this is very important to know. Here we are just working with a single code block. In my upcoming Rust Quickies, we will also talk about concurrency, about multi-threading, and as we will see, Rust also enforces those rules that we are talking here today across multiple threads that are running in parallel. So it's very, very important to know that Rust is memory and thread safe by default. This is one of the major benefits of Rust in comparison to some other low-level programming languages like C and C++. Rust is just memory and thread safe by default. I hope that you have enjoyed and learned today a lot about multiple references in Rust, and in my next Rust Quickie I want to talk about another interesting concept called lifetimes. So thanks for watching, stay tuned and see you soon. Thank you.